start this. All right, we're on lesson 50, trigonomic equations, starting on page 342. This is a lot of stuff that we've already kind of looked up to this point. We're just, again, adding new ways of looking at it. So I'm going to go ahead and flip over here to another page. Notice that we're looking for a range of values between 0 and 360, so we have options to go multiple times around the coordinate plane. So I'm going to move over here. Let's see if I got my paper. Here we go. So our question is this. Let's see, we want to solve cosine. Please tell me this is going to work today. Here we go. My computer's being super slow today. There we go. Cosine 2 theta plus radical 3 over 2 equals 0. Okay, so we want to solve for theta. So just like with any equation, we want to isolate theta as much as we can. So the first thing we want to do is obviously what? Subtract radical 3 over 2 to the other side. So it's going to give us cosine 2 theta equals negative radical 3 over 2. At this point, this is when we begin to take that ratio, representing cosine, with negative radical 3 over 2, and plotting it. So with cosine, we want to consider what is cosine. Cosine is adjacent over hypotenuse. All right, so we're looking for, we've got actually two locations where this occurs. It occurs in this quadrant, in quadrant 2, and in quadrant 3, because what I get is a negative radical 3 here, a positive 2 here, and a positive 2 here. Which leaves me with a 1 and a negative 1, which tells me this degree is what? What is my reference angle right there? 30 degrees. Okay, and I got 30 degrees here. Okay, but as I'm looking at the actual locations where these occur, okay, this one is at 150 degrees. This one is 30 degrees past 180, so it's at what? 210? So this is at 210 degrees. So what we're saying is that 2 theta is at 150 and 210, okay, to start with. Now granted, we'll be able to go multiple times around, but theta is going to take those and divide them by 2. Okay, so we should get something, what, like 75, and what else? What's that, 105? Okay, 105. Okay, and then we want to go around again. So we're going to take 150 plus 360. Okay, I'm going to let you guys do that math because I don't have a calculator in my hands. Should come out to something like 510. Okay, 510. We're going to take 510 and divide that by 2. Okay, should come out to like 255. Okay, and then 210 plus 360, which I think is 570. $561. Okay, and then 570 divided by 2, something like 285. Okay. Okay, as we're looking at this, is this really new information, or we're just adding kind of some new components to it? Okay, so my answer are those degrees right there, 75, 105, 255, and 285. All right. Okay, and if we went any further, we'd be shooting over 360, which is why we stopped there. Okay. All right. Try that again. All right. Let's come back and look at our next one. Solve the equation cosine 2x. Given we're looking, notice the difference here. Up here it was between 0 and 360 degrees. Down here, we want our answers in radians. Okay, so my recommendation here is solve everything out in degrees. Everything out in degrees, just like we did with the last question, and then at the very end, convert back to radians. Okay, does that make sense? Okay, so let's take this. We'll come over here. Again, I think your best mode here for what you guys need to be doing today is at least writing these down. As I write them down, you're getting to practice. Okay, all right, with this one we have 2x minus 1/2 equals 0. All right, the same steps are, I mean, you're going to see a repetition of steps. So the first thing I'm going to do here is what? Not yet. Add 1/2 to the other side. Let's see. Oh, and I'm forgetting that this is cosine. I knew we needed a trig function there. So we have cosine 2x minus 1/2. So we're going to get cosine 2x equals positive 1/2, correct? Okay. Now what do we want to do, Ryan? Now we want to put it on the coordinate plane. We're going to base this upon the trig function that we're using, which is cosine again. It is adjacent over hypotenuse. So we're going to have 1. We're going to have positive 1. We're going to have a hypotenuse of 2. So which two quadrants give me a positive adjacent value? 1 and 4. Okay. So we're going to wind up here and here where this is 1. Okay. My hypotenuse is 2. Which means these are radical 3, which means my angles are what? 60, okay, which is a true 60. There's 60 there, but this one comes out to what? Where's that line show up at? 300 degrees. Okay, that first one's easy to get. Does everybody understand the second one, how we got 300 degrees out of that? Okay, anybody missing that? Okay. All right. So what we're saying then is 2x. Okay. 2x comes out as 60 and as 300. Okay. So if we're looking for x, we're dividing by 2. Okay. It's pretty basic there. So we're getting 30 and 150. Okay. Then we're going to go around again. So we got 360 plus 60, which I believe is 420. Okay, divide that by 2, you get something like 210. Okay, 360 plus 300, so it's what, 660 divided by 2. 330, and so we're pretty certain at that point we can't go any further around, but because wanted to know between 0 and 2 pi, which is between 0 and 360. We need to convert 30 degrees into radians. How do I convert degrees to radians? Multiply by 180. Okay, so 30 divided by 180 comes out as 1. 1/6. What am I going to write? I'm not going to write pi over 6. Okay? So what's 150 divided by 180? Needed as a fraction. What am I going to write? 5 pi over 6. Okay, 210 divided by 180. 7 pi over 6. And finally, 330 divided by 180. 11 pi over 6. Okay, this is our answer for that. Pretty easy so far. We can do this. Great. Doesn't make any sense to me. Okay. All right. Let's see. We should be ready for 5. Now, this is going to change things up a little bit. Okay. 1, we're going to see a 2 cosecant squared theta over 2 minus cosecant theta over 2 minus 1 equals 0. So there's a lot going on here with this question. Okay? So let's go over here and see if I can't simplify this a bit for you. 2 cosecant squared theta over 2 minus cosecant theta over 2 minus 1 equals 0. This is how I want you to look at this for now. Is I want you to look at this cosecant squared theta over 2, cosecant theta over 2. I want you to look at those in terms of x. So imagine 2x squared minus x minus 1 equals 0. Okay, where x represents cosecant theta over 2. Okay, I'm just going to substitute it out because we've seen something like 2x squared minus x minus 1 equals 0 before, correct? Okay, and we could factor this, right? So we want to take this, we want to factor it down. Okay, well, because we're dealing with a 2x, we know we're going to get a 2x and an x. Now I'm looking at things, with this in mind that are going to multiply to be negative 1. Okay, well, obviously, in order to get a negative 1, the only things I can multiply to get a negative 1 are a positive 1 and a negative 1, correct? Okay, now let's check and make sure that all this comes out right. Okay, because I don't want to ever leave this and it's going to end up being wrong. So 2x times x is 2x squared. And then I've got 2x times negative 1, which is going to be negative 2x. 1 times x is going to be positive 1x, which is going to reduce down to negative 1x, right? And then positive 1 times negative 1 is negative 1, okay? So what we're going to do from this point is we're going to substitute that cosecant theta over 2 back in for x, okay? And we're going to solve both of these, okay? Remembering that we want to set them equal to 0. So on this one, it's 2 cosecant theta over 2 plus 1 equals 0, right? All right, let's make sure I got this. Yes?
Could you just solve the factor down to like where x equals 1/2?
So you're saying, okay, let's, you're saying if we got 2x plus 1 equals 0, you'd subtract 1, right? So you get x equals negative 1/2. So we end up with cosecant theta over 2 equals negative 1/2. Let's see if that'll work. And if that works, if it's easier, then we'll do it that way. Okay. Which would mean we'd need to come over here. Cosecant is reciprocal to sine, right? Okay, so let's see. That would make, right. Well, and our hypotenuse is at least in our special right triangles, is never 1, right? We don't have a hypotenuse that comes out as 1. So if you'll let me, I'm going to backtrack, and we might be able to do it this way, but for now I'm going to kind of follow my notes through this, if that's okay with you. Yeah, and I'm not saying that it's wrong, it's just that sometimes you kind of have to flip your brain around when you're used to doing something a certain way. In fact, let's start off with an easier one. Let's start off with this x minus 1. Okay? Okay. So we've got cosecant, let's see, theta over 2 minus 1 equals 0. So we're getting cosecant theta over 2 equals positive 1, right? Okay, now here's the nice thing about this one, is that remember that cosecant is the reciprocal to sine, right? So because 1 is 1 over 1, I can change this to sine theta over 2 equals 1. Because it's the reciprocal, it's still 1, right? The reciprocal of 1 over 1 is still 1 over 1. So we can change that to sine theta over 2 equals 1, or 1 over 1. So sine there being, let's see. All right. So if sine is 1, right? Obviously, we don't get a hypotenuse of 1, but we do remember that sine represents what? It should represent the y-axis, right? Where do we get our y-axis at with 1? What degrees? 90 degrees. Okay? So what we're saying is that theta over 2, okay, first shows up at 90 degrees. And really, that's the only place where it shows up, right? Because that's the only place where sine is positive 1. Okay? Now, we do have to stay within that range of 360 degrees, but notice that instead of dividing by 2, what am I doing here to solve for theta? Multiplying by 2. So what do I get? 180 degrees. And that's going to be my only answer for this part, right? Or sorry, for this one right here. Because if I went to, all the way around, and then I'm multiplying by 2, I'm way over 360 degrees. So my first answer is 180 degrees. Does that make sense so far? Okay, because we still have to solve the 2x plus 1. Okay, but in order to do that, I'm going to have to erase our work for that one right there. So can I do that? Do we have this down? Okay. Okay, so now let's work on this 2x plus 1. So we got 2 cosecant theta over 2 plus 1 equals 0. We're going to get 2 cosecant theta over 2 equals negative 1. Okay, I'll make sure that I've got this. Well, first off, I'm trying to figure out, I believe that the next thing that we need to do is divide by 2. Right? Okay, so we're getting, essentially here, we would say sine theta over 2 equals the reciprocal to that, so it would be what? Let's see. 2 over negative 1. Let's see. Because we're talking about, this is going to come out funky on that. For some reason, the only answer that I'm showing up with on this is just that 180 degrees. Okay, I'm going to leave this one here for a second. We're going to go to 6. I may have to look at the second half of number 5, see if there's anything else to that. There may be it might actually just come out to that same 180 degrees, and that's the reason that there's only one answer to it. All right, and then let's see, number 6. Number 6 is the same in a lot of ways, and hopefully I'll do a better job on number 6. We can go back and look at number 5 again. So I'm going to leave that there, and we're going to do this one. We've got 4 cosecant squared theta over 2 minus 2 cosecant theta over 2 minus 2 equals 0, which we're going to rewrite as 4x squared minus 2x minus 2 equals 0. The first thing I would do with that is divide everything by 2. that's going to get me down to just an x squared. Okay, so if we divide everything by 2, we're going to get x squared minus x minus 1 equals 0. Factor that down so we have just x. Let's see, should be, let's see, on that, with a 2 on the outside. Oh, hold on. This is 2x squared there because we're dividing by 2, which is giving me that 2x plus 1, x minus 1. Okay. So we can take this one again, which looks like we're going to end up with that cosecant squared theta over 2 minus 1 equals 0, which we've already solved that out. We know that that's coming out to 180 degrees. Okay, because we're adding 1. Cosecant is reciprocal to sine. Okay, multiply by 2 because we know we're getting 90 degrees. Theta equals 180 degrees, and again, that's their only answer for that. So I'm going to look at this a little bit further and see if there's anything else kind of sneaking in here that might be an issue for us, but right now we're just getting 180 degrees for both of those. Your assignment, I believe, I've shortened it down. It was 1 through 18, 20 through 23. Took a couple of questions off that to try to keep it at 20, so I believe it's 1 through 16. 20 through 23, it wasn't taking off a lot, but it took off some for you. All right, we'll stop there.